The vast emptiness of space holds wonders beyond imagination, but also threats that stir ancient fears within us. Imagine, if you will, looking up at the night sky, not with wonder, but with the cold dread of knowing a silent, unyielding rock is hurtling towards our fragile home. It's a scenario often relegated to blockbuster movies, yet for scientists and engineers across the globe, it's a very real, very pressing problem. What would we do? How would humanity respond to such a cosmic challenge? For decades, experts have been grappling with this very question, brainstorming ingenious ways to rescue our planet from an impending celestial collision. And almost all of these solutions share a common blueprint. Send a ship to intercept the asteroid, and then, gently or forcefully, nudge it off its collision course. It's a cosmic tug-of-war, with Earth's survival hanging in the balance. One of the more elegant solutions involves using the subtle yet powerful force of gravity itself. Picture a spacecraft sidling up to an asteroid, not touching it, but simply hovering nearby. Because everything that has mass also exerts a gravitational pull, this ship, though small in comparison to the asteroid, could use its own tiny gravitational field to slowly, steadily tow the massive rock off course. We call this a gravity tractor. It's a slow dance, requiring precision and patience, but it leverages the fundamental laws of the universe. Another idea transforms the spacecraft into a cosmic bulldozer, acting as a tug. It would sidle right up to the asteroid's side and, using carefully applied thrust, push it off course. Think of it like a harbor tug guiding a massive cargo ship. Or, for a more high-tech approach, a spacecraft could attach a mass driver to the asteroid. This device would then hurl the asteroid's own rocky debris into space, bit by bit. And thanks to Newton's third law, for every action there's an equal and opposite reaction, this steady stream of ejecta would send the asteroid moving in the opposite direction, slowly but surely diverting its path. Another method harnesses the power of the sun or focused energy. Imagine giant solar mirrors reflecting concentrated sunlight onto the asteroid's surface, or powerful lasers superheating its substrate. This intense energy would vaporize parts of the rock, creating jets of steam or gas. These jets, much like tiny rocket thrusters, would gently push the asteroid, altering its trajectory. And then there's the option that often springs to mind first: nuclear weapons. However, the dramatic movie scenario of blowing an asteroid into oblivion is actually the least likely to succeed. Fragmenting an asteroid could create many smaller, still dangerous pieces, potentially scattering the problem rather than solving it. A more sophisticated approach would involve exploding a nuclear device near the asteroid, not on it. The immense blast and heat from the explosion would act as a powerful, directional push, nudging the asteroid to safety without breaking it apart. One of the more elegant solutions involves exploding a nuclear device near the asteroid, not on it. The immense blast and heat from the explosion would act as a powerful, directional push, nudging the asteroid to safety without breaking it apart. While these ideas sound like science fiction, some are very much grounded in current technology. NASA and the European Space Agency, or ESA, are working on two versions of what's known as a kinetic impactor. The inspiration for this came from the 2005 Deep Impact mission, not the movie, but the actual spacecraft that rendezvoused with Comet Tempel 1. It sent a kinetic impactor right into the comet to study what lay beneath its surface. The unintended yet incredibly valuable result was that it slightly altered Tempel 1's trajectory, proving the concept. Building on this insight, NASA will launch its Double Asteroid Redirection Test, or DART, in July of this year. 14 months later, DART will embark on a daring mission, smacking into the small moonlet that orbits the near-Earth asteroid Didymos. Yes, even some asteroids, known as binary asteroids, have moons. About a sixth of all near-Earth asteroids are actually binary or multi-body systems. DART will collide with this moonlet, named Dimorphos, at an incredible speed of about 1.5 miles per second or 6.6 kilometers per second. This collision is only expected to change the moonlet's speed by a fraction of a percentage, but it will be enough for Earth's telescopes to confirm that a kinetic impactor could indeed work to alter an asteroid's path. The ESA had its own version, aptly named Don Quixote, after the famous character tilting at windmills. This mission would have featured two spacecraft, Sancho and Hidalgo. Sancho would have launched first, arriving at the target asteroid to survey it and identify the most effective impact site. It would then transmit these crucial coordinates to the Hidalgo impactor just before its own collision. Unfortunately, while a brilliant concept, Don Quixote is still very much in the development stage, awaiting the resources to bring it to fruition. DART and the Don Quixote concept are particularly exciting because they build upon already developed technology, making them viable for missions in the near future. But many of the other ideas we've discussed are still barely more than ideas. Even if they were fully developed and ready to deploy, all these solutions would require months, if not years, or even decades to be put into space and successfully execute their mission. This means that for any of these sophisticated plans to succeed, we would need a substantial, early warning of an incoming threat. And that, unfortunately, is the critical vulnerability. As we've often considered, a substantial warning, or any warning at all, may not always be a luxury we are afforded. The challenge of diverting an asteroid is immense, requiring unprecedented global cooperation, technological ingenuity, and a long-term vision. Yet it's a problem that humanity is actively confronting, moving from theoretical discussions to real-world tests like DART. It's a testament to our ingenuity and our profound desire to protect our shared home. What are your thoughts on humanity's cosmic tug-of-war? Do you find reassurance in these plans, or does the scale of the challenge still give you pause? Share your insights in the comments below, and let's continue this conversation about safeguarding our future among the stars.